We're given f of negative 2 equals 8, f of 0 equals 4, f of 2 equals 0, f prime of 2 equals f prime of negative 2 equals 0, f prime of x is negative for the absolute value of x less than 2, and f prime of x is positive for the absolute value of x greater than 2. F double prime of x is negative for x less than 0, and f double prime of x is positive for x greater than 0, and we ask to sketch the graph of f. The information about f tells us how high or how low the graph is. The information about f prime tells us whether the function is increasing or decreasing, or any maximum or minimum. The information about f double prime tells us whether the function is concave up, concave down, or any inflection points. We need all of these. To do this, we will first construct a sign chart for f double prime and f prime. For f prime, the zeros are negative 2 and 2. We were told that f prime of 2 is 0 and f prime of negative 2 is 0. F prime of x is negative for the absolute value of x is less than 2, which is anything between negative 2 and 2. F prime is negative. The absolute value of x less than 2 is the distance between the x to 0 less than 2. Any number between negative 2 and 2 has a distance less than 2 to the origin. F prime of x is positive for the absolute value of x greater than 3, which is more than 2 or less than negative 2. And so we have the sign chart for f prime from the given information. We will do the same thing for f double prime. We were told that f double prime is less than 0, which is negative for x less than 0, and f double prime of x is positive for x greater than 0. This is the sign chart for f double prime. We then combined both of these sign charts and make one big sign chart, which tells us whether the function is increasing or decreasing, concave up or concave down. From negative infinity to negative 2, the graph is increasing because f prime is positive, and it concave down because the f double prime is negative. From negative 2 to 0, the function is decreasing because f prime is negative, and it concave down because f double prime is negative. From 0 to 2, since f prime is negative, the function is decreasing, and f double prime is positive, and so the graph is concave up. From 2 to infinity, f prime is positive, so the function is increasing, and f double prime is positive, and so the graph is concave up. We then put in the x and the y coordinate system with these cut points to determine the interval where the function is increasing, decreasing, concave up, or concave down. We also have when x equals negative 2, y is 8. And when x equals 0, y equals 4. When x equals 2, y equals 0. And so the graph of f has to go through these 3 points. From negative infinity to negative 2, the function is increasing and concave down. And so going from the left up to negative 2, it had to go up but concave downward. From negative 2 to 0, the function is decreasing and concave down, but we need to connect the 2 points, decreasing, concave down. From 0 to 2, the function is decreasing but concave up, and we need to connect the 2 points as well. That is a decreasing and concave up. We might want to be a little bit more precise. And then from 2 to infinity, the graph is increasing and concave up. And again, we don't want to draw a straight line to make sure that it is clear whether it is concave up or concave down. This is only one possible answer. The answer is not unique. We can graph the curve going up steep and then go through this point, going down, concave down, and then going down, concave up, and then going up, concave up. It is entirely possible that we cross the x-axis. It's just that we don't have that information, and so that's why we start the graph up there. But again, the answer is not unique. We just need to graph one that satisfies the given condition, and this is the graph of f.